Good morning, student. So I'm preparing video lecture on some of the topic in basic mechanical engineering. Hope it will benefit you. As you can see, the first video lecture is on basic concept of thermodynamics. So by definition, thermodynamics can be defined as the science of energy. And thermodynamics is a Greek word, and it is a combination of two words. One is therm, means heat, and another one is dynamics, means power. In early stages, thermodynamics is all about converting heat into power. But so by definition, thermodynamics is a science of energy, and we see, for example, uh, one of the most fundamental law of nature is conservation of energy. It means energy neither be created nor be destroyed. In other words, during an interaction, energy can change from one form to another, but the total amount of energy remains constant. In this particular example of conservation of energy principle, a rock which is falling from a cliff, in average stages, its total energy means potential energy and kinetic energy is constant. In top, due to potential gradient, its potential energy is say 10 unit, but it is in rest and got no velocity, so its kinetic energy is zero. But when it fell off from a cliff, then its potential energy being converted into kinetic energy. So in this case, at any stage, total energy remains constant. So if you want to study the thermodynamics, there is a two approach. One approach is macroscopic approach, and another one is microscopic approach. So in macroscopic approach to the study of thermodynamics, that does not require a knowledge of behavior of individual particle, and in another, analysis is carried out by considering the position, velocity, and energy of each molecule. So in our study, we are going to study in microscopic way of approach of the study of thermodynamics. These are the some of the application area of thermodynamics. Human body, and some other applications are heating and air conditioning system, refrigerator, humidifier, pressure cooker, jet engine, airplanes, power plants, car radiator, refrigeration, and every other appliances which have the energy interaction. These are the some of the dimensions we used in thermodynamics. Basically, we use SI system of dimension and unit. So, so first topic in basic concept of thermodynamics is system. So, a system is defined as a quantity of matter or a region in space chosen for a study. So everything outside the system is called the surrounding, and boundaries separate the system and surrounding. Although thin boundary contains mass and so as volume, but to ease our study in thermodynamics, we generally consider that boundary has zero thickness and it does not occupy any volume in space. So so types of system. These are three. There are three type of system. One is open, closed, and isolated system. First, open system is also called control volume, because in open system we generally either fix or we use fixed volume or moving boundary. So by definition, thermodynamics dealt with energy interaction between system and surrounding. So in open system, both mass and energy interaction is possible between system and surrounding. And some of the example of open system are compressor, turbine, and nozzle. In closed system, energy interaction between the system and surrounding is possible, but mass interaction is restricted. In isolated system, both mass and energy interaction is not possible, so system cannot interact with surrounding. So for example of isolated system is universe. Now, the state of system. Condition of physical existence of a system at any state is defined as the state of a system. It has at a given state all the property of a system have fixed value. So properties of system. So any characteristics of a system is called property, and some of the most famous thermodynamic properties are pressure, temperature, volume, mass, enthalpy, entropy, and etc. So quantity which identify the state of a system. So in this case, state 1, a system has mass 2 kg, temperature is 20 degrees centigrade, and volume is 1.5 meter cube. And in another state, it has mass 2 kg, temperature 20 degree, and volume is 2.5 meter cube. So if we classify property, there is two property: intensive and extensive property. So intensive properties are those are independent of mass of a system, such as temperature, pressure, and density. And extensive property are those whose value depend on the size or extent of the system. For example of extensive properties are mass, total volume, and total momentum.